Welcome to the last section of Chapter 2. And this is the last section of your trig unit for Math 20-1. So this is all about the cosine law. So we learned about the sine laws. They weren't too bad to use, hopefully. It's using the opposite side lengths and angles and their ratios and how they equal each other. Now, the cosine law is also another very cool, useful law to use, and it's a little bit more tricky to use, I would say, just because there's a lot more going on. Now, here's something kind of interesting to think about. I'd probably suggest you maybe thinking about this on your own. If you want to chat about it, feel free to email me, or we can Google Meet or meet in person and kind of talk about it. But here, let's talk about the key ideas. So again, you're going to usually deal with a triangle. Again, are they always going to be notated like this? Absolutely not. But I would recommend, even if it's notated differently, I would change it so it looks like this. Because when it looks like this, it's way easier to apply your cosine laws. So your cosine law is found here, and it's found in two different ways. One where we're finding the angle, one where we're finding a side length. Now recognize that they have done the algebra for you here, which is very nice. So here is the first sine law or cosine law. Again, we are notating our side lengths with little letters or lowercase letters, and then capital letters for our vertices or our angles. Recognize when you're solving for a specific side length, you are cosining the opposing or opposite angle, okay? And then you're just dealing with the side lengths. So if you know all side lengths, and if you know all the side lengths except for one, but you know the opposing angle of that one you're trying to find, you can find it. Whereas on the other hand, as soon as you have every single side length, you can find any angle that you want, which is very, very nice. So let's bring this down and try out a few questions. So example 1 here. Determine the unknown side length to the nearest tenth of a centimeter. So notice this is a great example because these are all different letters, which is kind of a pain. Let's change these so it matches our cosine law. So there's nothing saying that these have to be X, Y, and Z. Let's make this A. Well, I gotta actually kind of see it first. Let's make this A, B, and C. Now, why have I done that? Because now this is going to be B. Whoa, that's not true. This is opposite of angle A, so this will be little a. This length is opposite of B, so this is little b. And this length is opposite of C, so this is little c. And now we can get rid of these notations. Again, it's good to know what we're trying to find. Find X, so therefore find A. So now we're just trying to find A. And now we have our triangle represented in terms of our data sheet, which is very useful. Now, in order to use this, we are trying to solve for a side length. We know both other side lengths and we know the opposing length. So therefore, we're going to use this cosine law. In this case, I've actually notated this one as A, which kind of works out. So now it's just A squared equals B squared plus C squared minus 2BC cos A. And it's a matter of now plugging in. So A squared is going to equal B squared, which is 18, plus C squared, which is 15, minus 2 times B, which was 18, times C, which was 15, times cos A, which we figured out was 46. So let's plug these in. You could do it all at once or one at a time. I'm probably going to do it one at a time to begin with. So this is 18 squared, so 324, plus 15 squared, 15 squared, which is 225, minus 2 times 18 times 15, and then times cos 46. Remember to be in degree mode. So that gives us 37.11552. Let's add up all these values. So 324 plus 225 minus 375.11552. So that gives me 173.88448. And recognize this is now solving for the square of a. So I'm going to have to square root both sides. And even though we introduced a square root, we're not going to take the positive and negative because having a negative value wouldn't make any sense. So I'm going to press square root. I'm going to press second square root. Let's make sure I get rid of that square. Oh, looks like my calculator wasn't too happy with me with that one. So second square root 173.88448. So we get a to equal 13.186 centimeters. And let's make sure we note that with what it wants. It wants it to the nearest tenth of a centimeter. So I'm going to round it to the 1 decimal place. I'm going to round it up because the number to the side of it is greater than 5 or equal to it. So 13.2 centimeters. And there's your value of x. So you could also state that x equaled this. And there we go. We have now figured out using our cosine law. This one a shot. I'll go through it now. So hopefully you tried it on your own. And if you feel confident, that's awesome. We see till the end if you got it correct. And if you got a little confused, that's why I'm going through it. So determine the unknown side length to the nearest tenth of a centimeter. So here, this one, it does have it notated as ABC, but this is where people get a little too hooked on the formula sheet. Here, we're not actually going to be solving for A. We just need to know how to apply this formula here. Because this, we already know, this is A, because it's a opposite of A. 40 degrees here, this would be B, little b over here, because it's opposite of angle B. Opposite of angle C, so this would be little c here. So now at this point, we're trying to find B. So what does that mean for us? Well, we have both other side lengths, and we have the opposing angle. Therefore, we can now use our cosine law. Recognize we're not going to put a squared, we're going to put b squared. The most important thing about the cosine law is recognizing that whatever side length you're solving for, you have to have the other side lengths and then the opposing angle of the unknown side length. So I'm going to actually write this. So it's b squared equals c squared plus a squared minus 2 times c times a times cos and the opposing side angle b. If you really needed to, you could always rearrange all the notations so the unknown thing you're always solving for is a. I wouldn't really recommend that. I would just get used to understanding how to use this with any given labeled triangle. So now at this point, it's a matter of plugging in. So b squared is going to equal c squared, so 10.5 squared, plus a squared, so 9.5 squared, minus 2 times 10.5 times 9.5 times cos 40. So at that point, we now have our numbers to plug into our calculator. Okay, I'm just going to quickly move this over. So now it's a matter of plugging in. So b squared is going to equal, and let's plug this in. So again, you could technically do this all at once, but for the sake of our notes, I'm going to write it all down. So 10.5 squared, 110.25, 9.5 squared, it's 90.25, minus 2 times 10.5, 2 times 10.5 times 9.5 times cos 40. So that gives me 152.8258664. And now I'm going to add up all of these values. So 110.25 plus 90.25 minus, I'm going to press second answer. And remember, when you press ants, that's the previous solution. So that's going to give me 47.6741. And from here, I'm going to square root. Don't forget to square root. Everybody always forgets to square root. So I'm going to square root that answer. And that's going to give me 6.90. And we want to round to the nearest centimeter. So I'm just going to round this to 6.9 centimeters. And there is your value of B. And that makes roughly a decent amount of sense. You can see here 9.5, 10.5. We can clearly see that B has to be in between those side lengths. So you can always kind of check and reason through if your solution kind of made sense to you. Okay, so hopefully that made sense. Hopefully you were able to get that solution, and if you weren't, you were able to understand by me working through it. So let's move forward into some new examples here. So let's look at example 2. And example 2 says determine the angle R to the nearest whole number. So in this case, notice you have been given no angles. If you were given one of these angles, you could just use the sine law, which is way easier. But since you have no given angles, but you have every single side length, you can use the rearrangement of the cosine law. Recognize here that we have not been given our, it's not labeled as A, B, C. So what I'm going to do is I'm going to label this as A, B, and C triangle. Recognize that this has a solving for cos A. So I'm going to make the angle I'm looking for, which is R, I'm going to make that A. So I'm going to notate this as A, and then it doesn't really matter what you notate the other ones. And now you can say that this is little a, because it's opposite to A. This side length here, 5.9, would be little b, and this side length here would be little c. So now you have everything kind of worked out, and you're ready to solve. So A equals 2.3 meters, B equals 5.9 meters, C equals 6.2 meters, and we're solving for A, angle A, which is just angle R. So now we can just go over here and notice, hey, I have all of these things and it's already set up the exact way I would like it. So cos A equals B squared, so I'm getting this from here, B squared plus C squared minus A squared over 2 times B times C. And now I have these values to plug in. So 5.9 squared plus 6.2 squared minus 2.3 squared over 2 times 5.9 times 6.2. And this is going to be the cos A ratio. So I'm going to pull out my calculator, and I will get 5.9 squared plus 6.2 squared minus 2.3 squared. Divide that by 2 times 5.9 times 6.2. To make sure all of that is laid out properly. Looks like it. So this is going to give me 0.928922. Now recognize this is not your angle. This is the cos A ratio. So to figure out the angle of A, we're going to take the inverse cosine of this number. So second cosine, and then I'm just going to press second answer, because remember that answer is the previous solution you just found. So this will be 21.7 degrees. And what does it run us around to? The whole number, nearest whole number. So this will be 22 degrees. And there's your final solutions. We found angle A, which is angle R. So this is 22 degrees. And there you have it, folks. We were able to find our solution using our cosine law. So if you have any questions, please come in and ask on that one. Let's move on to a few more examples here. So I would suggest giving this one a shot for sure. Hopefully you're able to solve it. Maybe pause the video, give it a try, and now I'm going to solve it now. So hopefully you tried it, you paused the video, and let's see if you were able to get the proper solution. So here it wants us to find angle Z. Again, notate it so the thing you're finding is A. Makes it life way easier. So this will be A, B, C. We're trying to find angle A, so angle Z equals angle A. Now we know that this is little a. This here would be little b. And this side length would be little c because it's opposite of c. So now it's a matter of plug and chug. So 2.9, b is 2.6, c is 2.2. And from here, we can use our formula. Cos A equals b squared plus c squared minus a squared over 2 times b times c. So cos A is going to be 2.6 squared plus 2.2 squared minus 2.9 squared over 2 times 2.6 times 2.2. Let's check here. So 2.6 squared, squared. This calculator's a little touchy sometimes. Squared plus 2.2 squared minus 2.9 squared. So that gives us 3.19 on the top, divided by 2 times 2.6 times 2.2, 11.44. So 3.19 divided by 11.44. So that gives me 0.2788. Again, this is not your angle, this is your ratio, and we have to take the inverse of cosine to solve for the actual angle. So I'm going to do second cosine, second answer, and that will give me an angle of 74 degrees. And now we have found angle Z, which also equals angle Z. So hopefully you're seeing that the cosine law is very powerful, and it can be quite easy to use as long as you set everything up nicely for yourself. So I'm going to stop the video here. I'm going to make one final video going through example 3, and then you should be pretty good to go with trigonometry. If you have got lost anywhere, please let me know. Other than that, have a great day.